So in this video, we are going to discuss about the problem solving template you have in module 2 notes. So this template is used to reduce some of the common mistakes that you are going to make when you solve problems, and also to encourage you to show all work that will be needed to on all the points in your exams, quizzes, and homework assignments. So there are 4 steps you can use to solve a physics problem. First, you should visualize it, and then you have to plan a solution, execute the plan, and then check and evaluate the solution or the result. So let's see. The first step, when you visualize the problem, you have to draw a sketch or a diagram of the situation. And also for this chapter, you can draw a motion diagram. So by looking at the motion diagram, you can tell whether the object is speeding up or slowing down, or whether it's moving at a constant rate. And also you have to next define a coordinate system. So it is really important to define a coordinate system. You can consider either right as positive or left as positive. It doesn't really matter as long as you're clear and consistent, because in this chapter you're working with vectors. So vector has not only a magnitude but also a direction. So the direction is really important. You should define the coordinate system at the beginning of the question. And then you're going to identify the known and unknown quantities and constraints. For example, let's assume objects or a car start from rest and move with a uniform acceleration of let's assume 10 meters per second for 5 seconds. So now if you look at that example, you know the initial velocity is 0, starts from rest, and move with a uniform acceleration of 10 meters per second, and let's assume it takes 5 seconds to move a certain distance. So if I ask you to calculate the final position of the object, you should first identify the knowns and unknowns. You know the initial velocity, it's 0, and then the acceleration is 5, it's a known quantity, and also you know the time interval, or the elapsed time, is 5 seconds, and the unknown quantity is the final velocity. So if I ask you to calculate the final velocity, you should be able to list down the knowns and unknowns under this section. Okay, and so you can just list them either off to the side or label the diagram with these quantities. And then applicable concepts or chapters. So this is also really important, because if you look at this chapter 2, so we talk about 1D kinematics, 1D free fall, and then in chapter 3 we are going to talk about 2D kinematics, and then after that we're going to talk about Newton's laws, conservation of momentum. So it's important to identify the general approach to the problem, what physics concept you're going to be tested on. So just make sure to pay attention to that as well. And also you have to identify the symbol of what you're trying to find and expected sign. So that is also really important. So when you predict the sign, you can look at the coordinate system and then predict the sign based on the coordinate system. And next step is to plan a solution. So when you plan a solution, guys, you have to look into your equation sheet and look at the equations that describe the identified physics concepts and principles. And if you have, like, let's suppose, like, in the equation, uh, you have certain quantities that you already know. So in that case, you can just put a check mark over variables you know, and the value of, and a question mark over a variable that are unknown. And then you can determine if you have as many as equations as you as the unknowns. For example, if you have just one unknown, one equation is enough to solve for that one unknown. However, if you have two unknowns, you need to have two equations to solve for those unknown quantities. And next, you have to execute the plan. So once you have planned the solution, this step, the third step, is really easy, but you have to make sure that you pay attention to rules of algebra to obtain the expression with the unknown variable on one side of the equation and all the known variables on the other side. And also you should substitute specific values into the expression to obtain the arithmetic solution for your problem. Now, next, when you do this step, it's important to check the units, because you can get the wrong answer with the right units, but the right answer cannot have wrong units. So suppose you're solving for the acceleration and you end up of getting meters per second as the unit. You should know that you're making some mistake somewhere in your calculation or in the plan, so that you should go back and check your work again. So next step, the last step, is to check and evaluate. So you have to check whether the solution is complete, whether you have, you can look back to the symbols of what you're trying to find out, and then you can come here and see whether you have already solved for those unknown quantities, and then is the sign of the answer correct. You can go back to the expected sign, and then you can compare with the expected sign. And then does the answer have the correct units? So that is really important. Suppose you are solving for velocity, so you should end up of getting meters per second, and if you just get meters, you should go back and see what's going on there. And then the last step is the magnitude of the answer reasonable. So these steps, the four steps: visualizing the problem, planning the solution, and executing the plan, and then check and evaluate. Really important, and definitely going to guide you when you solve problems throughout this course. And for this video, I focused on the questions that you're going to see in kinematics, 1D kinematics. So just go back to your module 2 Node packet and look at the example questions. So we have done a lot of example questions, like you can see videos for those questions, and first do them on your own, and then go and watch those videos to see where you're making mistakes, so which areas you can improve, and just make sure to do your best.